Find the Maclaurin series for a function 5 sine 4x cubed. In the notes we did find the Maclaurin series for sine of x, and we did that by actually taking the derivatives. The Maclaurin series can always be found by the sum n equals 0 to infinity, nth derivative of the function, plug in 0, times x to the n divided by n factorial. However, that can be really hard to find a pattern. So we're going to actually do this one just like we did for the previous quiz when it says find a power series. It just happens that now we know it's called a Maclaurin series. If you find a power series around x equal to 0 for a function, it's a Maclaurin series. So we'll just use the one that we found for sine of x. That was the one that turned out to be the summation n equals 0 to infinity, negative 1 to the n. Sine and cosine are both alternating, and sine is the odd one. Sine is an odd function. Also, if you put in a negative x, you can pull out the minus. That's the definition of an odd function, and so it has odd powers. And then the factorial matches the power. Okay, so if we start out with using that sine of x formula, then all we have to do is substitution, multiply it by the, in this case, constant 5, maybe by a power of x as well, but this time just by the 5. And we do have those other two methods, which would be differentiating and integrating. Actually, if you differentiate sine of x, you get cosine. But we also have a formula for cosine memorized that you can use directly from the notes. That'll be for the quiz problem. But here's the example of using sine of x, so you can follow it with cosine in the quiz problem. So we'll go ahead and make it sine of 4x cubed. And remember that the order of operations here says you always do this multiplication on this side before taking the sign. And of course you do the exponentiating before you do the multiplying by 4. So I need to just think of that as being inside of parentheses. Just don't need those, but it helps me see where to put it in the problem. So I get n equals 0 to infinity, negative 1 to the n, 4x cubed, parentheses, 2n plus 1, all divided by the 2n plus 1 factorial. And then one more thing to do is just to multiply by 5 to get our final answer. And you can multiply on the outside of the summation, or you can just skip that step and multiply right on the inside of the summation, because you're multiplying everything in the sum with all pluses between them by the same 5. And so I'll get equals n equals 0 to infinity, 5 times negative 1 to the n times that 4x cubed to the 2n plus 1, still divided by the same thing. And one step that we should probably do is at least combine the powers of x. Use any rule of exponentiation that you can do to make it a single copy of x to a power. I won't make you simplify all the way to re-indexing to make it x to the n, but at least we'll combine the powers. Okay, 5, negative 1 to the n, and we have 3 and 2n plus 1. Also, the 2n plus 1 has to go on the 4. So there's that, and then 3 times 2n plus 1. You could make it 3 times quantity 2n plus 1, or you can do 6n plus 3. that's where I say you can stop. That's good enough to see the Maclaurin series for it. And this one actually combines some stuff that you'll have to do for both of the quiz problems, because one of them has just cosine, and the other one has e to the x squared. So this is a little harder than both, but it's not that hard. There's just a couple of steps to do. Substitute, multiply by 5. You just have to be really careful with parentheses and basic algebra. So you have to put parentheses around the whole thing so that when you simplify by putting the 2n plus 1 in on the x and the 4, you don't miss any of it.